Mistakes that you should avoid. And I realized some students made these mistakes during the test. I checked it, I graded manually, and gave you the points. Don't worry if you made this mistake, I gave you the points. But after the due date, you still can work on the test, but make sure you don't fall for those mistakes here. Let's go over real quick. First one, don't add spaces in the math answers. No spaces, you don't need spaces. Space is for if you're writing a text, if you're writing a sentence, if you're writing a math answer, don't use spaces. It will make the answer wrong. Don't forget the variable, and this is a very silly mistake some students made. If they write the coefficient and they write the exponent and they forget to write the variable. Very, very silly mistake. Be sure to remember about the variable, write the variable. Next one, use the correct variable is another one. Sometimes it's not X, it's R, or it's A, or it's a different variable. Check the question, what's the variable that you're working on. Don't use the wrong variable. Answer in the simplest way. This is important for any math answer. When you are providing your answer, you have to simplify. The fraction, if you have a fraction like this, you have to write the simplest way. It's 3, right? If you have parentheses, you have to clear the parentheses. If you have like terms that you can combine, you have to do everything before you write your answer to simplify the expression or the equation or the answer that you're working on to write the simplest way. Answer with fractions instead of decimals. Most of the questions I ask you to use fractions instead of decimals because, yes, we know that 3 over 2 is 1.5, right? But sometimes you have, instead of 3 over 2, you have 4 over 3. And this is hard to represent in a short decimal. That's the reason you just write the answer using the fraction, the simplest fraction that you can find, and just keep it as a fraction. Don't write as a decimal. Write polynomials in the right order and descending order of exponents. If you have x squared plus x cubed, so this is the first one, then this is the second one, and the last one is x. And if you have a constant, this is the last one is the constant. Something like that. Descending order of exponents to have the right order of the polynomial. Careful with exponents. And this is very silly because check this out. The student press the button to write exponent and forget to turn off the exponent. Then the whole expression becomes an exponent. This is wrong. See? Another situation is when the student just forgets to press the button to make this an exponent. And instead of 10 exponent 9, it is just 109. That's wrong. Scientific notation. You have to use the multiplication sign here, not x. There is a multiplication sign. And the first number is digit, decimal point, and another digit, always. If you have more significant figures, so you add the significant figures. If you don't have, you just add at least 1 0 after the decimal point. Don't use X, asterisk, or dots, or period, to represent multiplication. No, there is a multiplication sign. Let me show real quick here on forms. There is a multiplication sign on forms. If you click on it, check this out. This is multiplication, this is X. So don't use X, use multiplication when necessary. Because most of the time, you don't need to use anything at all. You have to suppress the multiplication symbol whenever possible. let's say 3xy. You're not going to represent 3 times x times y, right? No. You're going to represent like this, 3xy. No multiplication symbol. Same thing if you have to factor out and you have parentheses. Is x plus 2 times x minus 1. You suppress the multiplication sign here in the middle. Don't need. That's it. Any questions about the silly mistakes that you made? But I gave you the points. Now on, if you work on the test, if you work on a quiz, I'm not going to check and give points for these silly things, okay? You have to be careful. Questions? Any questions? Any comments? Any feedback at all? Did I forget about any mistake? If you remember about anything, you can tell me. I think I covered most of the mistakes that you now have to avoid. And if you're working on the test, you still can work and you still can have a very good grade, as long as you avoid these mistakes here. We have a new chapter, a new month of February starting today, and Chiara is asking here. So the system is going to be giving us the grade. Yes, Chiara. Yes. For the test, for the test. So let me see here. John Lee, I'm having connection problems and kicked me out of the meeting. I tried back, but it keeps kicking me out. Okay, John Lee. Check if you're in the right. Let me send a message to John Lee. For February, check this out. We have chapter 5, rational expressions and rational equations, starting today. It will take 14 days, and then we have a holiday, Rodeo Day on the 19th, Friday 19th. And after the holiday, the next week, then we start chapter 6. And we're going to have a test, maybe at the very end of the month. At the end of the month, I think it's going to be at the end of the month. Better. Okay? So, this is the new chapter, a new month with a new chapter, and those are the topics that we're going to cover on this new chapter. 5.1, 5.2 multiplication and division, 5.3 addition and subtraction, 5.4 complex fractions, and 5.5 solving rational equations. All this about rational expressions and rational functions. Today we are starting. Let's understand what is a rational expression and what is a rational function. If we, and I know you love the fractions, right? We love to work with fractions, and I know you don't. But let's say we have this fraction here, 5/3. We can think this as a monomial over a monomial. Monomial as the numerator and a monomial as the denominator, if they are like constant factors, constant terms of a monomial. That means this can be, you can say this is a rational expression. It's a rational number, but yeah, but it's more clear if you write like this, 5x over 3y. See, this is pretty clearly a rational expression, because you have a monomial as a numerator and a monomial as a denominator. So it's a rational expression. Another rational expression, 5x squared minus 4 over 3y minus 1. This is a rational expression as well, because you have now a binomial over a binomial. If you have a polynomial over a polynomial, you're going to have a rational expression. Now, what is the rational function? We kind of understand what is a rational expression, but what is a rational function? A function is going to be a rational function if it can be written in the form. So now we're going to have to, you need to have the function notation f of x equals p of x, another function, over q of x. So it's a function over another function. And we can say it's a polynomial. Let's say an example here, 5x squared minus 4 over 3x minus 1. This is an example that it might be a rational function as long as you write with the function notation. Okay, so we know what's a rational expression. We know what's a rational function. Let's check how to evaluate, evaluate and finding the domain of rational functions. We will start with very simple, very easy examples and questions, because we are starting a new chapter, right? Remember that last week we worked on kind of hard questions because we are at the end of the chapter 4. Now we are at the beginning of chapter 5. We will start kind of slowly and gradually we will increase the level of difficulty. Right now, very simple, very easy. Check this out. How to evaluate a rational function? Given the function, and we have here g of x equals 2 over x minus 3. Determine the function values. This is how we evaluate the function. Find g of 0. To find g of 0, what are you going to make? The first step is to make x equals 0. Plugging x equals 0 into the equation, into the function. So g of 0 equals 2 over 0 minus 3. And 2 over 0 minus 3 is negative 2 over 3. This is the answer. So g of 0 equals negative 2 over 3. Okay, this is how you evaluate a rational function. Very simple, right? Let's try another example. G of 2. Okay, g of 2. You have to make x equals 2. Then plugging x equals 2 into the equation or the function. 2 over 2 minus 3. And 2 over 2 minus 3. 2 minus 3 is negative 1. 2 divided by negative 1 is negative 2. Negative 2 is going to be the answer. So g of 2 equals negative 2. Right? Pretty simple. Just plug in into the function and find the result. Now check an interesting one, very interesting one. G of 3. What's going to be g of 3? Well, plug in, make x equals 3. Plug in into the function, g of 3 equals 2 over 3 minus 3. And now you can calculate. Oops, wait a minute. If I make 3 minus 3, we're going to find 0. How can I divide 2 or any number by 0? How can I work this out? That's a big problem. What can I do here? Can someone help me out? We have 2 over 0. What are you supposed to do in this situation? We cannot divide a real number by 0. It's not going to result a real number, a real solution, right? What's the answer here? Anyone remember? Can anyone help me? Would be just 2? Maybe, Chiara, let's think about it. We are dividing 2 by 0. And the answer, usually when you have something like that, is the... So questions about it? Can you see that we cannot have the denominator equals to 0? It will produce no solution, is not going to have a solution, the real number. So we will exclude, we will remove, we will ban the number that makes the denominator equals to 0. And the number in this example here is x equals 3. We will make the domain all numbers except 3. 3 is excluded, is banned, is deleted from the domain. Questions? Any questions? If you don't have questions or comments or anything at all or complaints, maybe we can move on. You can check all the solutions here for all the numbers. The procedure to find the domain of a rational function is step number 1. Set the denominator equals to 0 and solve the resulting equation. And step 2, the domain is the set of all real numbers, excluding, deleting, removing the values found in step number 1. Okay? I think I'm not going to work on these examples. We can spend more time working on the quiz, practicing together. Now, if you have questions, type it out or turn on your mic and tell me. If you don't have any questions, let's go on and work on the answer for the bell work. What do you think? Very simple. Add one line to make it fine. How would you change and add one tiny line and make this equation true? Send me now your messages. I want one message from each one of you. Let me just record. For this bell work, the 2 possible answers. You can move and make a line here on the first plus sign and transform into a 4. So you're going to have 545 plus 5 equals 555, and this is correct. And there's another answer, it's a bit boring. 5 plus 5 plus 5 plus 5 is different from 555. It is a possible answer. I think the first one is more creative, but the second one is also correct. Okay. Check this. Evaluate the rational functions. This is the first question of the quiz. Pretty simple. We need to find f of -6. You need to plug in x equals -6 into the function 5 over -6 plus 1. Then you have 5 over -5. And this is equals to -1. This is the right answer. Okay? Do the same thing for each question up to letter F. Letter G is a different kind of question. Find the real number that must be excluded from the domain. And letter G is kind of easy. Let's try letter J. On letter J, just focus on the denominator. The denominator cannot be 0. So you make t plus 3 different from 0. You don't want 0. To have t plus 3 different from 0, you need to have t different from -3. Right? And this is going to be the answer. -3 is the number that we need to exclude from the domain. Because we don't want the denominator to be equals to 0. Now, work by yourselves for 1 minute. I will check attendance real quick, and I'll be right back so you can work together in more questions of the quiz.